Hello, let's continue our Sudoku adventure with Berry Berry Chex by rockratzero. So this is an indexing puzzle. We have normal Sudoku rules, 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these indexed cells that are individually highlighted. So what do those mean? Well, the red cells tell you where that column number goes in the row. And we have little arrows to help us out. So for example, if this cell here were a 4, we look at what column it's in. It's in column 1. And that tells you that the 1 goes in column 4. See that little arrow pointing all along the row to help us out. So this 4 means that that's a 1. If it were instead, say, I don't know, if we're allowed to be a 3, then the 1 would go here. And then the blue ones, that's the same, but we kind of rotate it, right? So what's our example? If row 1, column 1 is a 3, then that's in row 1. So we place the 1 here in row 3. If this were a 4, that's in row 3. So that means that we need to place the 3 in row 4, which would go there. So hopefully that makes sense. It's basically just an indexing constraint. But normally we're used to like an entire column or an entire row being indexed, and instead it's sort of sporadic cells. So hopefully the arrows help you out. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started now. All right, I think we have some gimmies because this 4 places a 2 in column 4. This 5 places a 2 in row 5. That places a 5 in row 2. That places a 5 in row 5. So that stops there. It placed itself. Okay. So let me think about this cell. This places the 1 in the row. So it could be a 1. It could place itself. It could also be... It can't be a 3 because there's a 3 in the row already. It could be a 4, like the example. But it can't be a 5 because there's already a 3 there, and it can't be a 6 because there's a 6 in the row. So this is 1 or 4 only. So that means that the 1 in this row is here or here only. This places the 1 in the column. I think that's pretty open, but it could be a 1, it could be a 2, it could be a 3, it can't be a 4, it could be a 5, and it can't be a 6 just because okay. Well, so that actually tells us something. It can't be a 6. If this were a 1, this would have to be a 6 because it's placing the 1. Because it's in row 1. It's placing the 1 in this column, right? And it can't go in row 6 because it's not allowed to be a 6. So that means that this can't be a 1. So this is indeed the 4, like the example, and then that's a 1. Okay. So this is a pair then. This is 2 and 5, and we know the order. So this 5 now places the 6 here. Okay. The box finishes with a 4. This box finishes with a 1 and a 3. If this were a 1, that would be a 5. That seems okay. Let's see. If this were a 3, this would be a 5. That seems okay. This places the 6 in this row. So it can't be a 1. It has to be 2. It can't be a 2 either. So it'd have to be 3 or 4, but it can't be 5. And it can't be 6. So the 6 is in one of these. I don't know that that's helpful. In general, we need 1, 3, 4 here. It's not a 4. I'm looking for... Okay, these cells are a triple, and they have 2 indexers on them. So let's take a look. So we need a 3, 5, and 6 here. That's not 6, that's not 5. So let's look at this one. This one is telling us where the 4 goes. So it's actually just pointing at our 4 in the 5th slot. Okay. This is telling us where the 4 goes in the row, because it is column 4. So that means the 4 either goes here or here. If this was the 4, let's take that a step further, then that places the 3 here. which doesn't work. This can't be a 3. No, this would self-reference. That would be fine. Never mind. That works just fine. So either way works with this 3, 6. This column needs a 1, a 4, and a 6. Okay, 6 in this box is here. 6 in this box is here. Ah, so 6 in this box is placed. 6 has to go here in this box. This is 1 or 3. That makes a 1-3 pair, so that's not 1 or 3. So this is, oh yeah, that is pointing at 2, 5. Interesting. So this is also 2, 5, but I was going to say that might help with where the 1 can go, but it worked itself out. These are from 1, 2, 3. Maybe that's helpful. If this were a 2, this would be a 1 because of the indexing, and so then that would be a 3. 5 would make this a 1, that a 3, and that a 1 or 2. Okay. I was kind of hoping it would have some weird effect there, but I don't think it did. 5's in one of these two. Okay, this places the 3 in the column. So it could be 1 or 3 or 4 or 5. Darn. I guess that means it's not 2. So one of these is 2. We have a 2 in the column already, so that doesn't matter. Okay, this places the 3 in the row, which can only be, oh, this can't be 3 because that would be a 2. There we go. So this is a 1. These are not 1s. That's a 4. That's a 3. And so then this tells us where the 3, it tells us the 3 goes in 3. Okay, so that's self-reference. But I think we might be actually finishing now. That's a 3. 2, 5, 4. We already knew that. Okay, that's 3. This is 2. We knew that as well. Okay, this is just finishing. Okay, cool. Well, neat puzzle, Rock Rat. Nice use of indexing there. There were a few cases that were just failures to scan on my part where like a pencil digit in a index cell actually wasn't possible anymore because of how things worked out in its row or column. But the arrows were definitely helpful in remembering which one was which. So thank you for including those. I hope you enjoyed this as well. And if you did, then why not leave a like, subscribe, and a kind comment below.